Good morning to Dr. Dayang and my fellow friends. So today my group will present about the product that we created for the product design project. The title of our project is Home Bladeless Wind Turbine, and we are from environment elective, and my group mate is So Yun Jin, me, and Huza Idayu. So I will start my presentation with this is the picture of our product, our wind turbine. It is a small size wind turbine which is uh, only applicable for residential user, and it has no blade, and it utilizes the resonance phenomena to oscillate the wind turbine and generate electricity. So there are four central attributes of our product, which is the first one, it's efficient clean power. So using vortex technology, our wind turbine harvests energy from fluid when it goes through the surface, which eventually produce an elastic oscillation to the turbine, which means when the wind go through the turbine, it will vibrate and absorb the energy. And the second one is lower cost, because our turbine does not have blade and gears and bearing, so this turbine reduce the cost of manufacturing, operation, and even maintenance. So the third one is environmental friendly. Our wind turbine is a renewable energy source that reduce the carbon footprint with no oil and contaminant needed for maintenance. It is also harmless to wildlife because uh, it reduce noise. We don't have the blade. Usually the blade produce a lot of noise that cause harm to birds and wildlife. The final attribute is a low startup wind speed. It has a low startup wind speed, which is estimated to be 1.5 meter per second. So the structural attribute is like the first one, it requires less maintenance. This product does not have blades, gear, and brakes, so it does not need much oiling and maintenance on some part. So the second one is lightweight and manufactured using less raw material. Less raw material used for this project. Raw material used for this product are significantly low to normal wind turbine due to its fewer parts. So less part of the product also contribute to its lightweight characteristic. It's not heavy because it has less component. The third one is harmless to wildlife. No blade reduce its stretch to birds. And the fourth one is harness wind from any direction. Our wind turbine can detect wind from any direction due to its geometry, because it's a hollow circle. So when the wind come from like a different side, they don't have to like move so that they can detect the wind. So it is cutting its time response to detect the wind direction. Microstructure. Microstructures such as materials play an important role for this product, because the selection of material that is very crucial in this product, because it affects the tensile strength, weight, lifetime, and even the cost of the wind turbine. Material that has low density, high tensile strength, easy to produce, and recyclable and cheap are the best selection for our wind turbine. Besides, composite fabrication method of mine will also affect the strength of our product. So I will pass my presentation to Ayu. Thank you.
Next, the domino theory of our product is what drives our team to produce more bladeless wind turbine technology is the wind itself. The wind is a pollution-free renewable energy source that produces no pollutant in the air or water. It does not pollute the air with particulate matter such as nitrogen oxide and sulfur dioxide by fossil fuel, like coal or natural gas. It does prevent the acid rain, smoke, or greenhouse gases impact. Besides, energy generated from the wind is sustainable for future needs. Low power wind turbine can be used to harness the renewable energy and bring electricity across the grid, especially to the small household areas. Moreover, the technology of wind turbine with multi-bladed is possible to install and harness energy in Malaysia because the country is located at a low wind speed region. So the multi-bladed turbine has several fundamental flaws that have prompted us to develop a bladeless turbine. Uh, they have high maintenance cost due to the mechanical components like gears, windings, and other effects that were linked to the friction that requires oiling and maintenance at some parts. The blades also pose high risk to the flying wildlife, where the rapid oscillatory movement of the blade usually kill the birds and bats. Besides, the multi-bladed wind turbine also produce high initial installation costs because the expansion of multi-bladed turbine correspond to a significant rise in the capacity of its construction, thus increasing the cost of installation. Next, the possible chemical that triggers our product is the acid rain. Um a common pollutant A common pollutant from industrial processes such as sulfur compounds or sulfuric acid react with water in atmosphere, thus it forming acid rain. The acidic rain condition give a synergistic effect on turbine material. Um, the delamination between fiber layers, pit formation, development of microstresses occur as a result of acidic rain condition. Thus, it resulting in the loss of reinforcing fiber adhesion. Over time exposure to acid rain, it will harm the fittings and structural components of wind farms. Also, the turbine's operation and maintenance processes will be affected, which are directly related to the high energy generation cost, low performance, poor efficiency, and reduced longevity of wind fields. Next, for the scale-up approaches of our product, first approach is the theoretical scale-up, where the geometry and material remain the same, and also the height to diameter remain the same, which greater than 6. The weight and power of the turbine is scaled n to the power of 3 and n to the power of 2, where n is known as the scale-up factor. Finally, the cost analysis is carried out and the optimal sizing will be determined um, at the most cost-effective uh, product. Next, for the scale-down approaches, the product, uh, our product is already small, so the scale-down is not beneficial because um, our product, where our product is when it's smaller in size, the energy generated also low. Next, for the design function, the turbine installed perpendicular to the fan of the air conditioner, where it is ideal for urban infrastructure or private houses. The release of exhaust air from the compressor of the air conditioner provides a high speed of the wind to the turbine bladeless. Therefore, it generates wind energy. The turbines uh, convert wind power into electricity through vibrations, and the phenomenon is known as vortex shredding. The the design generate energy at low wind speed, at which the maximum power can be generated at an earlier stage. Um, Moreover, since the bladeless wind turbine consists of a few moving parts, the cost of maintenance and manufacturing tends to be at lower cost.
Now let's move on to the specifications of our product.
So start-up wind speed is actually the minimum wind speed where the wind turbine start to operate, and our product is 1.5 meter per second, which consider low. And the nominal output power is 400 watt. The mass material that we use is carbon glass fiber hybrid in powder epoxy because it can reduce the cost and the weight of our blade of our turbine. Sorry, it's not blade. And since our product is in small size, so the height is only 550 mm, and the mass is estimated to be 1.16 kilogram. The road material that we use is carbon fiber, and the road mass is 0.15 kg, while the type of generator that we use is permanent magnet generator. So we actually go through two patterns which is similar with our product. Both of these patterns, they have no blades and also utilize resonant phenomena to oscillate the turbines and produce electricity, which is similar to our product. What is different is that the body material, which is the mass material that we use, is carbon glass fiber hybrid in powder epoxy, while for the US patents, they are using carbon fiber and glass fiber composite. And the size, ours one is focused on small size wind turbine, while those patents, they are have in larger size, which their height is more than 1 meter. And the shapes, as you can see, it's for the Europe pattern is on the left side, for the US patterns is the right picture. And ours one is conical hollow cylinder, which similar with the Europe patterns shapes for the mass, but we mounted on the flexible beam instead of ground. And the type of wings that we use, not only just natural wind, but we also utilize the exhaust air from the air conditioning condenser, because if we solely only depends on the natural wind, it's not enough to generate the electricity and not efficient since Malaysia have low wind speed. So what's different that we use the waste air from the air conditioning condenser. And house of quality, we list out all the customer requirements, which include efficiency, strength, lightweight, low maintenance cost, noise pollution, impact on birth, and include the technical requirements too. And we determine the relation between these two requirements. We also rank the importance on the customer requirements for each importance of each requirement, where the highest rank is 5 and the lowest is 1. And you can see efficiency and cost have the highest ranking. And we also compare our product with two competitors and see and rank their customer competitive assessments and technical competitive assessments for each product. And now I proceed to the life cycle analysis. Our products is 400 watts home bladeless wind turbine, and the boundary that we set is start from material extractions until the disposal of our products, and we expect that our wind turbine have a lifespan of 25 years. So start with material extractions and proceed to manufacturing, transportations, and operation maintenance, finally disposal. So here show the mass, material, and mass of each component for one 400 watts home bladeless wind turbine. The generator magnet that we use is neodymium, and the coil is copper coil. So this shows the energy consumptions and carbon dioxide release of each phase, and you can see that
if recycling taken place, it actually can reduce 2,800 2.8 power of 4 joule of energy can be reduced, and 0.75 kg of carbon dioxide released to the environment can be reduced too. So thanks, that's all from us.